So let's go through this example of slicing that 2D array in Python. So if I run this code, so we can talk through it. So here's the basic syntax for slicing a 2D array. What you get here is separated by a comma is the row. So row that you want to access, and then this is all related to the columns that you want to access. So here, when we say we want to access row 0 to 2, what we mean by that is that's row 0, that's row 1, and that's row 2. But this number 2 is exclusive, so it doesn't actually include this row number 2. So 0, 1, 2. This row will be excluded. Then you have columns. So columns 1 to 3. So what does that mean? If we look at this is column 1, this is column 2, and this is column 3. When we say 1 to 3, it will basically give you, that's column 0. So this will be column 1 and column 2. Again, 3 is exclusive. So you do not include this. So it leaves you with 2. I have 3 as the columns. But then we had the row criteria, which is also include row 0 to 2. So that's 0 and 2. But since 2 is exclusive, so you only include these 2. So by the virtue of this, it is this row, and then this column and this column. So we end up with a result, as you can see here, of 2, 3, and 6, 7. And if we look at the next example, which is extract the third column. So for rows, what we are saying is we don't sort of care about the row. Instead, we want the column extracted. So what do we mean by that? So if you look at this, the criteria says extract the third column. So which one is the third column? That's 0, that's 1, that's 2. Now, if you look at that, this time, what we're saying is we want to start at 2, and that's the only column that we want. So that's 0, 1, 2. So now we get 3, 7, and 11 because we have specified no rows to be extracted. And if we look at this one, extract the second row. So here, how does that work? So we haven't specified a column. Instead, we specified just a row number. So that's 0, and that's row number 1. So we just get the output here, 5, 6, 7, 8, as shown here. And then finally, we have this one, extract the top left 2 by 2 subarray. So here, let's go through this. It's easy to understand once we go through it. But you can see here, there is no starting figure provided. So no starting index is provided. So we go with from the beginning, the row. So that's 0, 1, and this is 2. So here, immediately 2 is excluded. So it's exclusive at this time. So what we do is it has to be one of these. So then the next criteria is up to the second column starting from 0. So that's 0, that's 1, and that's 2. So that means 2 is exclusive. So you do not include 2. So you just include this 1 and 2 and 5 and 6, which is what this syntax here is telling you. So here, as you can see, we've got the extract 1, 2, and 5, 6. So this is the syntax for slicing a 2D array in Python. As you can see, it's very easy to understand. You just need to remember the rules around what is excluded. So this number is always excluded, but if the number is by itself, like here, 2, then basically you include that number. So like in here, when we said extract the third column, so 0, 1, and 2, this is the third column. This time it's not exclusive, so you won't end up with like 2, 6, 10. Instead, you end up with 3, 7, 11. As you can see here, 3, 7, 11. So that's a simple rule. When you get a number after a colon, that's exclusive. And when you get a number without a colon, then it's basically that specific number. So 3, 7, 11. This was the third column. But since it's all 0 index based, you start in 0, 1, 2. So I hope this makes sense to you. It is very easy to use, and it can do a lot of wonders for you if you use slicing arrays in Python. So this is how you can filter a Numpy array in Python. So here, let's say we have the following array. And what we want to do is we want to filter to say whenever we get the value that is greater than 25, then we want to store that in this second array, array 2. So what you do is you reference the first array, which is ARR, and then you put at the square bracket as though you are accessing it by index. And instead, what you do is you type the array variable name again, and then put whatever condition that you want. So in this case, I'm looking for values that are greater than 25. So you put 25 in there, and what it will do is it will output a mask, and that mask will in turn give you false for the first 2 elements, and then it will give you true, 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 which means you will get the following elements. If I run this, so as you can see, we've now got an output which is 30, 40, 50, which meets our criteria. And then we got array 3, which is we are now applying 2 conditions using the AND. So this now is going to do a logical AND. So this means we access it the same way as before. So you put it as though you've got a square bracket, and then in the square bracket, you put in your 2 conditions. So you do array less than 50, array less than 50, and then this will get processed, and you will then get an output such as 30, 40, because that means it's greater than 20, and it's less than 50 in these 2 elements. Now, what about if you actually want to know where those elements are? So what is the index number? So what you can then use is using the Numpy where function, you can pass it an array, and then what you can do is say it is greater than 25. So this is meeting our first condition. So that's pretty much the same, other than we don't use square brackets anymore, or you just use these parentheses here, and then you can print out the indexes. So as you can see here, the indexes have been printed out. So you can see that the element that we were interested in, which were 30, 40, 50. So that's index 0, that's index 1, that's index 2, 3, 4, 2, 3, 4. And that's the output we get here, 2, 3, 4. So this is where, and you would use iterate and Boolean indexing to quickly extract elements or filter elements from an array using Numpy module in Python. You can easily carry out arithmetic operation on Numpy array using the following code. So here it's very easy. If you've got two arrays, array 1 and array 2, and you want to add them together, so what you can do is just add a plus and array 1 and array 2, and what we'll do is it will add the two elements. So if I run this, and as you can see, the output that we get for this one, it will add each element, corresponding element to from array 1 to the array 2. So if you look at this one, we've got 11, 10 plus 1, 11, 2 plus 20, 22, 3 plus 33, 33, and so on. And subtraction works the same. You will get a -9. Now notice it's doing this, array 1. So 1 minus 10 will give you a -9. 2 minus 20 will give you -18, and so on. And then here you can multiply against each other. So 1 times 10 is 10, 2 times 20 is 40, 3 times 30 is 90, and so on. And division works the same. So here, as you can see, these are the results that we get when we divide. And then finally, we have an array that is squaring the elements. Now notice here, we're no longer multiplying or doing anything with the second array. Instead, here we are squaring the element. So by squaring here, you can see 1 by 1 is 1. And then we've got 2 by 2 is 4, 3 by 3 is 9, and 4 by 4 is 16. So notice that this time we didn't use the second array. Instead, we multiplied or squared the elements by itself in array 1. So yeah, this is how you do arithmetic operations such as addition, subtraction, multiplication, division, and squaring, either using two arrays, or you can actually supply your own values that you want to add, subtract, or multiply, or square, or divide by. So just remember that each element worked on individually. So wherever you supply in the first array, it will get the corresponding arithmetic action on each of its elements. So this is how you do arithmetic operations on a 2D array in Python using the Numpy module. So here what we have is two arrays being declared. So they are 2D arrays. The reason they are 2D arrays is because you've got two columns and two rows here. So that's the row, first row, and this is the second row. And again, second variable here, again, it's a 2D array. And what we are doing is adding the arrays together. So what will happen is, how do they work? So if I run this, and as you can see here, we've got 11 as the first output for the addition. So how did we get to 11? We got first row, and this is the second row. And for the first row, we got in the very first column, we got number 1. And in the second array, in the first row, at the very first element, we got a 10. So if you add that and that, you get 11. And if you add 2 and 20 on the first row of both arrays, then you get 22. And the same would apply to the second row now. And the first element, so this is 3 plus 30, which would give you 33. And then you've got here 4 plus 40, which would give you 44. And the same way multiplication would work. So multiplication is here, though it's 1 by multiplied by 10. So first row, first column. So that would give you 10. Then it is second column in the first row, and then second column in the first row for the second array. So 2 times 20, that gives you a 40 there. And then you move on to the next row, which is 3 multiplied by the second row first element. It's 30. So 3 by 30 gives you 90. And then you've got 4 times 4, which is 16, but it's 4 multiplied by 40. So that'll give you 160. So that's how the arithmetic operations work on 2D arrays. Is basically corresponding row, corresponding column, multiply to each other to give you the arithmetic operation using the Numpy array in Python. So this is how you do scalar operations using Numpy in Python. So this is a Numpy array, and it's a 1D array. And what we want to do, a scalar operation, and what we mean by scalar operation, also you might say broadcasting, is we want to add a number to each of the elements here, or multiply or divide. And this is what is known as scalar, because this side here, you only have a scalar number. You only want to do the same number again and again. So it's not like an array, addition by array. So here, it will add 10 to each element. So if I run this, as you can see here, each of the elements here will get added a 10. So here 1 will become 11, 2 will become 12 because we added 10, 3 will become 13, and so on. And same with multiplication. So here 2 would be multiplied by 3, which would give you 6, 3 multiplied by 3, which would give you a 9, and then here you get the division in the same fashion. So this is known as a scalar operation or broadcasting in Python, which is you take your array and you apply the same operation, in effect, the same scalar value on all the elements of the array. And this is sometimes also known as broadcasting. So this is how you can do a dot operation in Numpy. So what you do is, let's say you've got two arrays. So this is our first array, array A, and array B is our second array. And what you can do is multiply arrays together, but using the dot product. So the way the dot product works is you can use this notation and pass it A. And so that's the array A, and then the second array, array B, separated by a comma. Or you can use the at symbol, the alternative way of doing the dot operation. So what this dot operation will do is basically multiply the first row element. So here we have 1 and 2. So this 1 will get multiplied by 5, and this 2 will get multiplied by 7. So if I run this, you can see 1 multiplied by 5 and 2 multiplied by 7. So this gives you, and 2 multiplied by 7. So this gives you 14. 14 plus 1 times 5 is 5. That gives you 19. And then the same thing would happen against second column of the second array. So here we get 1 multiplied by 6 and 2 multiplied by 8. And that would again give you 22 there. And then the same thing would happen with the second row. So here 3 would get multiplied by 5, and then 4 would be multiplied by 7, and this would give you the 43 there. And then finally you would get 3 multiplied by 6 and 4 multiplied by 8, and this would give you 50 over here. That's how you do a dot product in Python. So you've got two dot type choices, one which is using np dot and then supply the two array names, and the second one is just by using the @ symbol. If you are new to Visual Studio Code and you're trying to input some Python code and you're getting an error, so here if I try and run this code, you'll see that I get an error to say np is notified. So usually in Visual Studio Code, if you hover over the error message, you can usually do a quick fix. So a quick fix will normally resolve a lot of issues for you in Visual Studio Code. So as you can see here I am not importing in the np module, and you don't even know what np is, but Visual Studio is clever enough to work out what np is, and that's the Numpy module. So if I go here and select quick fix, and you can immediately see it's recommending the first one fix is add import numpy as np. So that's the missing statement. So if I click on that and add that in, it will add it. The second part, search for additional import matches or add type ignored. These two are not really relevant. Usually the first one will fix it for you. So if I click onto that one, and as you can see, it's added in the missing statement that was needed in my code for it to work. And now if I run this code, you can see my code has worked. So this is really useful in Visual Studio Code, just to use quick fixes. It may help resolve a lot of issues that you may be having. In Numpy, you can apply universal functions to your array. So let's say I have this 1D array and I want to apply one of the universal functions of the Numpy module. So what we mean by Numpy universal functions? So these are functions that are normally of mathematical nature, such as square root, exponential, natural logarithms, sine, cosine. So as you can see here, I just applied with my array name, and it would apply that to each of the elements within here. So if I run this, and as you can see, if I square root at each of these, this is the output that you get. Square root of 4, for example, is 2, square root of 9 is 3, square root of 16 is 4. So this is what you would get, is it would apply to each of the elements in there. An exponential as well, so you can see that's being applied there. Natural logarithm, sine, and cosine. So this is how you apply universal functions in Python using the Numpy module to your array.